Hey everyone, and welcome. Today, we are diving into something really cool from DeepSeek AI. And look, this isn't just about AI scanning text anymore. We're talking about a model that's learning to read a document the same way you and I do, by actually following the logical flow of the page. This is the story of a breakthrough called DeepSeek-OCR 2. Okay, so let's get right into it. To really get why this new AI is such a big deal, we first need to get our heads around the fundamental problem they're trying to solve. And it all comes down to how computers, how they see the world. So I want you to picture a page from a magazine or maybe a complex report. You've got columns, pictures, tables, the whole shebang. How does a normal, everyday AI model actually process all of that? I bet it's not how you think. Yeah, this right here shows you the old, kind of clunky method. Most AIs read in what's called a raster scan order. Just imagine a lawnmower, It starts at the top left, goes line by line, all the way to the bottom right. It's this totally rigid path that has zero concept of columns or figures. To the AI, it's all just one flat grid of text. So here's the kicker. This clumsy method completely shatters the document's logical structure. You'd read the first column, then move to the second. But the AI, it reads the first line of both columns, then the second line of both columns. And you can see how the meaning just gets completely jumbled. This is exactly why AI has, for so long, struggled with even basic things like forms, reports, and academic papers. But what if an AI could learn from the most advanced optical processor we know of, the human eye? Well, this is exactly where the DeepSeek team found their inspiration. And this quote from their paper just nails it. Think about it for a second. Our eyes don't just blindly scan a page. They follow the meaning. We jump from a headline, down a column, maybe over to a picture, and then to its caption. Our path is driven by our understanding of what we're looking at. And that brings us to their core concept, something they call Causal Visual Flow. It's this simple but powerful idea that where you look next is directly caused by what you just saw and understood. The researchers use this great analogy. When you trace a spiral with your eyes, you're not just scanning a grid, right? You're following a continuous, logical path. So how in the world do you actually build this kind of human-like intuition into a piece of software? Well, the DeepSeek team's answer was to create a fundamentally smarter way for the AI to see, a new kind of vision encoder. And the result of all that work is DeepSeek-OCR 2. The breakthrough at its heart is a brand new architecture they call DeepEncoder V2. This is the engine that really drives that human-like reading capability. This slide just lays it all out, plain and simple. On the left, you've got that rigid, nonsensical scan we talked about. But on the right, the new way with DeepEncoder V2, it's a total game changer. Before the main AI even tries to read the words, the encoder looks at the whole page and creates an intelligent plan. It figures out the correct reading order first. Okay, so this idea of creating a reading plan sounds awesome, but how does the encoder actually pull it off? Let's break down the mechanics a little bit. It basically works in 3 main steps. First, the AI gets a global view, kind of like us glancing at a whole page just to get the lay of the land. Second, it uses what the paper calls causal flow queries to plot a path. Think of these as the AI asking itself questions like, okay, that's a headline, where does it lead? I see a picture, where's the caption? It's figuring out what's the most logical thing to read next. And finally, step 3, it sends that perfectly ordered sequence of information over to the language model to be understood. And this diagram here, this is basically the secret sauce. It's a custom attention mask, which is just a fancy way of saying it's a system that lets the AI do 2 things at once. It can see the whole page globally. That's kind of like our peripheral vision, taking in the whole scene. But at the same time, it creates that step-by-step logical reading order, which is like our focused, sharp central vision. It gets the big picture and the details in the right order all at once. Pretty clever. Okay, so the theory is brilliant, but you know how it is in the world of AI? The proof is in the performance. So does this human-inspired approach actually work any better? Let's take a look at the results. Well, on a major industry benchmark, DeepSeek-OCR 2 showed a, get this, 3.73% performance jump over its predecessor, which was already really powerful. In this field, that is a significant leap forward, and it validates the whole approach. But if you dig into the numbers, that's where the real story is. Yeah, the overall score went up, and that's great. But look at the crucial metric, the reading order error. It dropped a lot. And that shows the AI isn't just getting more words right, It's fundamentally getting the structure of the document right. It's actually understanding the layout. And that's why this is such a big deal. This isn't just about building a better tool for reading PDFs, not at all. This represents a fundamental shift in how we can teach AI to understand our visual world. I mean, the researchers themselves think this could be a major step toward what they call genuine 2D reasoning. And that makes sense, right? Language is one-dimensional. It's just a sequence of words. But the world, a document, a website, it's two-dimensional. This model starts to bridge that gap by teaching the AI to understand the logic of a 2D page before it even tries to read it. So where does this all lead? Well, the horizon here is huge. The same kind of architecture that learns to read a document could, in theory, learn to reason about any visual task. The paper even suggests this to be a path toward a unified omni-modal AI. We're talking about a single system that could learn to understand images, audio, and text using the same fundamental principles of causal flow. So when you boil it all down, here's what we're looking at. We're moving from AI that just processes pixels to an AI that perceives meaning and structure. And that leaves us with a really fascinating thought to end on. What happens when our AI systems learn to see the world not as a static grid of data, but as a dynamic, interconnected web of meaning? The possibilities are pretty exciting to think about.